limit x tends to 0, under root 1 minus, again under root cos x by x. We have in the form of 1 minus cos 0 is 1, right? 1 minus 1, which is 0 by 0. Okay, so let us try to rationalize this. Okay, we have this in the form of 0 by 0, right? Let us try to rationalize this and see how whether we can remove these zeros. This let us multiply with under root 1 plus root cos x by under root 1 plus again root cos x. The conjugate of this, right? 1 plus root cos x, 1 plus root cos x. Cos x, then what will become? The numerator will become under root a plus b into a minus b. That is 1 minus root cos x, 1 square minus root cos x whole square, which is nothing but 1 minus cos x, right? 1 minus cos x by x into under root 1 plus again this under root cos x, right? 1 minus cos 2 theta. Cos 2 theta is 1 minus 2 sine square theta. We know this, right? So what does that mean? 1 minus cos 2 theta is 2 sine square theta is equal to 1 minus cos 2 theta, right? So 1 minus cos x is actually equal to 2 sine square x by 2. So square root of this obviously will be the absolute value of this, because square root can be positive only, right? So this becomes square root of 2 sine square theta, 2 sine square x by 2, which is nothing but square root into absolute value of sine x by 2, right? Now we have this x will write it as 2 into x by 2. This 2 will get cancelled. So right, x we can write it as this. Why? Because we have sine x by 2 and x by 2. Now 1 by under root 1 plus under root cos x, this will take as is. Now we want the limit at x equal to 0. That means when we approach from the left hand side or from the right hand side, we should get the same limit. Now let us try to approach this problem, right, from the left hand side. From 0 minus when we are approaching, x is negative. So sine of x by 2 is also negative. Sine of minus theta, right? Sine minus theta is minus sine theta, right? We know this, right? So this function becomes root of minus of root 2 by 2. That is 1 by root 2. That is this part, into sine x by 2 into x by 2, right? Plus 1 by under root 1 plus root cos x, right? This becomes, when we substitute when x is tending to 0, this part will tend to this part, right? Limit, this part will tend to 1, right? And this part 1 plus 1, which is again root 2. So basically minus 1 by root 2 into 1 by root 2, which is equal to minus half, right? But when you are approaching from the right hand side, right, then absolute value of sine x by 2 is positive. So sine x by 2 is also positive. Absolute value is sine x by 2. Everything else remains same. Instead of this minus, it will be plus. When you are approaching from the right hand side, we are getting 1 by 2. So left hand limit is not approaching right hand limit, not matching with right hand limit. So sine x by x, this graph will look something like this, right? So it will approach 0 when sine x by x. But when you are putting absolute value of x, what will happen? This left side graph, it will not approach 1. It will approach minus 1, right? It will approach minus 1. When you're putting absolute value of x, sine x by x, then it will approach, the graph will not be like this. The graph earlier also we discussed that there is no limit, because one side you are approaching minus 1, another side you are approaching plus 1, right? So sine x by 2, because there is an absolute value function here, when you're approaching from the left hand side, you are getting a minus 1 by 2, right? And you're approaching from the right hand side, you are getting plus 1 by 2. So this limit actually doesn't exist, right guys?